Yeah, hi guys. Today we are going to see some important concepts in AWS, and we will start with the very first concept that is called as anycast and unicast. So, what is unicast and what is anycast? Let's understand the concept first, and then we will move ahead. These are very important from AWS certification point of view. So, let's say I have a server S1 and it has IP1. So one server, one IP. This is a simple case and you call it as anycast, unicast. After that, assume that one server and can it have multiple IPs, multiple public IPs? No, this is not possible. But it is possible that you can use one IP for two servers, server 1, server 2. What is the advantage? Let's say a user U1 is there, okay, he have got this IP, user U2 is also there, he also got the same IP, and when he will use this IP, this user will access the nearest server. When user 2 use this IP, he will be redirected to S2. So the same IP is utilized and user access S1, user 2 access S2. So this concept is called as anycast, where one IP is getting used by two servers or multiple servers, so that whenever user will send it request, it will be that request will reach to the nearest server. Okay, and this concept of anycast is used in AWS Global Accelerator. Okay, now let me erase it. Now, Global Accelerator. So let's say I have a user U1, okay, and he want to contact and he is in USA. He don't want to use internet of USA. Okay, no, no internet. He don't want to use internet of USA. Instead, he want to use some infrastructure of AWS. And anyhow, his application resides in India. So what happens whenever he will try to access Indian server, okay, there will be some intermediate device called as edge location. So his traffic will flow through the edge location, okay, and then edge location will forward this user request to India. So this edge location, okay, this edge location will act as a intermediate station between the sender and receiver. Okay, and here it is using actually AWS internal global network. Here we are using AWS internal global network. Again, the case is user U1 is there, he is in USA, he don't want to use internet of USA, instead he want to connect to India. For that, AWS will provide him edge location, and in that edge location, through the edge location, he can forward the traffic to India and he can access the application. Okay. Now, this same example I am repeating again. This time I am saying that this is the app, okay, and this app have got two IPs as we have discussed. IP1, sorry, edge location 1, or okay, this app got two IPs, okay, IP1 and IP2. So or simple one IP, because it is any cast case. Since it is any cast, I can assume it has got one IP. So whenever user of particular region, okay, try to access, he will access its nearest server, okay, and using the IP he can access nearest server. So nearest edge location will serve it, and the nearest edge location will forward its traffic to particular app. Here you can see clearly that edge location is forwarding the traffic to app. Now global accelerator, okay, has got two external IPs. He has got, let's say, two external IPs. Okay, this external IP can be used by VPC, by EC2 in VPC. It can be attached with application load balancer, network load balancer. Okay, this global accelerator can be used in application load balancer, in uh, network load balancer. Okay, it provide the facility of, this is a global accelerator, this is the external IP, and this can be used in VPC in EC2, can be attached to EC2 or ALB or NLB. Its advantage is health check. It can provide health check. Okay, it can be used for disaster recovery, failover. It can provide failover failover detection within 1 minute. This is the advantage of this. Okay. It can be attached to private and public network. It can be attached to private and public network. Okay. This external IP, this global accelerator have it provide intelligent routing. It have a consistent performance. It provide intelligent routing. Cache of client is preserved. It provide internal AWS network, as I have shown you, internal AWS network. Okay. So these are few advantages of it. As we know, this global accelerator, okay, now it support TCP, it support UDP, it also support HTTP and HTTP, it support HTTP, and it also support non-HTTP protocol also. Okay, when you use TCP, you get better performance improve. Okay, when you use TCP, what it do is it actually take your packet, make a proxy packet of it, and then it is sent to server. Okay, edge location. At edge location, take the packet and make a proxy packet. At edge location, as you know, cache can be stored because it contains cacheable content, and it also contains dynamic content, cacheable content and dynamic content. At edge location, these are the facilities, so performance get improved. It can be used for HTTP or non-HTTP, and it ultimately, in short, this actually provide you wide range of content. It provide you wide range of content. So this is about global accelerator. Let's talk about Docker. What is Docker? If I say Docker, what is Docker actually? So assume that you have a disk. You have a disk of, let's say, some software. Name it as Apache. You have a disk of this Apache app or software. I call it as a software. What you do generally, you go to your CPU, insert this disk, okay, in this tray. You just insert this disk, and then you copy it in some D drive, okay, folder. You just copy the disk, and after copying the disk, then you install it in, let's say, C:/program file, okay, /Apache, yeah, app1. Now this happens, okay. This is your normal scenario. What happens in case of Docker? Same thing, little bit difference. Why it is different? There is a store. You name it as Docker Hub. Okay. In case of Amazon, it is Amazon ECR. What it contain? Actually, it contain all the disks or software images. We call it as images. These are what? These are your software images. It means your apps. Okay. This is Docker Hub, and within Docker Hub you have software images, collection of software images. What Docker do? What Docker do actually? It download software image, okay, on your host machine. This is your host machine or your machine. It create a container, just like your C:/program files, like your program C:/program files. It install the app or install the software, plus it run the app within the container. Okay, so if I say that this is a Docker container, you can start it, you can stop it. As soon as you start it, app get start or app get stop, depending on your container. If it is on, app will on. If it is off, app will be also off. This Docker container, it can run on any machine. It can run on any machine. Within that container, as I said, we can run the app, we can install app. It may be DB, you can keep DB, you can run OS, you can run app. Okay, what is the advantage of this? Let's say you have an on-premise system, okay, and this is your cloud. So you want to lift and shift app, lift and shift app from on-premise system to cloud system. So this, in that case, this Docker will help you. It will be very helpful for you. Okay, now let's go in deeper in this Docker concept. Now let's say you have a image, okay, which is inside either Docker Hub or it is inside the Amazon ECR, Elastic Container Registry. This is Docker Hub, and all of them contain actually collection of images. These are the images, let's say, images collection. Now, this is the image. You download it. On your host machine. This is your host machine. Download it. Little bit about this Docker Hub. This is a public repository. Amazon ECR, it is a private repository. But that Amazon ECR also have a public gallery. Which outsider people can access. These are outsiders, okay, can access. Here also outsiders can access because it is a public repository. So outsiders can access it. What about this private repository? Outsiders cannot access it. Okay, that private repository is nothing but ECR, Elastic Container Registry. What is the difference between Docker and virtual machine? So, Docker and virtual machine. When I say that you install a Docker, on the other hand you install a virtual machine. So whatever operating system you install, okay, so within that operating system you install VM, okay, and whatever the resources, total resources you have, okay, this is a parent OS and this is VM inside that parent OS. So maximum resources it will use. Even if you install a simple small software, but maybe that VM which have a child OS inside it, it will take maximum resources, while Docker take only the required minimum resources. This is the first difference. It take maximum, it take minimum. Secondly, this Docker, okay, apart from taking minimum resources, it share the resources with host machine. It share the resources. It claim it and then it also share it. Okay, it share the resources with the host machine. Let's say this is the host machine, and these resources, okay, these are getting shared by both Docker as well as host machine itself. You can run multiple container. You can run container 1, container 2, container 3. So you can run multiple container. Okay, you can run multiple container. It is more secure. It is 100% virtualization, you can say, while this is partial virtualization. Okay, this is 100% virtualization and this is partial virtualization. Now, let's say you have a user machine, okay, and you have a Docker container. You have installed Docker, and as soon as you download the software image, from that image you create a container. Okay, from that image you create a container, then you install the software in that container plus you run the software in that container. So this is a Docker container. Call it as a Docker container. This is your host machine. Now what happens? There is a Docker script. There is something which is called as a Docker script. Okay, and within the Docker script you have some Docker commands. Using that commands, what you can do is from the Docker hub, or it may be Amazon ECR, from the Docker hub, okay, you can pull the image. Okay, so instead of manually installing the software, using the Docker script and using the Docker command, you can pull the image and you can directly install it on Docker container. This is your Docker container. Then you can, this is your container, you can start it, you can stop it. So similarly application will also behave. It will also start or it will also stop based on what activity you do. So from Docker hub you can pull the images using the Docker commands. You can install it and run it on host machine, and you can start and stop the container. All right. Container management. So as I said you that there is a Docker container. There is a Docker container. Okay. I want to do that management of container. I have 4 options. First option is ECS. Second option is EKS. Third option is forget. And fourth option is ECR, Elastic Container Service, Elastic Container Registry, Elastic Kubernetes Service, and this is the Fargate, which is a serverless service. Now we will look at ECS first and then Fargate. What is ECS? Actually, Elastic Container Service. What it is? ECS. So there is a option launch type and you choose EC2. When you choose launch type EC2, what happens? Okay, so here is a scenario. A user, okay, he goes to his host machine. He have a Docker container, okay, and he can start it, he can stop it. Let's assume he start the Docker container. Now what happens? A cluster get created having one master and few worker. This is called as ECS cluster. Master is the controller, workers are the working nodes. This this thing, this kind of cluster, it is called as ECS cluster, get created. Master actually is nothing but EC2 machine. Worker is also EC2 machine. Okay, everywhere you have to install EC2, and then they all collectively will create a cluster. One will become master, whichever you have configured, and those you have configured as worker will become worker. So there are some commands like join command. So based on the join command, all the other nodes other than master, they become part of this cluster. So let me really draw it again with minimum nomenclature. So this is a master node, which is a EC2 actually. Then there is a one more EC2, which is a worker 0, one more EC2, which is worker 1, one more EC2, which is worker 2. Along with this, there is something which is called as agent, and in that agent, something called as task runs. In agent, some task is run. Let's say T0 task, T1 task, and T2 task. Master and this all three worker, they create a ECS cluster. Okay, so this is master node, this is agent, this is EC2 worker agent, EC2 worker agent 2, EC2 worker agent 3, and each agent have associated task with them. Just label it as every master have some workers, and each worker have an agent, and that agent have a task. Okay, these are all setup which you have to do. So ECS cluster you will manage. You will create, you will manage. If you want, you can change it. When I say there is an agent, so actually that agent register itself on the cluster. So agent, what it will do, it will register itself and then it will run the task. It will register itself on the cluster, then only it will become part of that cluster. Okay, and then it will run the task. What AWS can do for you here is AWS can start and stop your container. Maximum this thing AWS can do here, but everything you have to manage. AWS will not manage it for you. Okay, because this is something called as, you have created this cluster, this ECS cluster, so you have to manage the ECS cluster. Whereas the other type, which is called as Fargate, which is serverless, everything remains same. Again, everything remains same, just one difference, no EC2. Okay, so AWS manage, okay, server. In worker also no EC2, because AWS is managing worker, AWS is managing worker 2, AWS is managing agent. Agent 1, agent 2, agent 3. AWS is managing the task of agents. In case task increase, AWS can auto scale worker plus tasks. AWS can do auto scaling of worker and tasks. Okay, so everything is managed by, because it is serverless. So serverless means AWS fully managed. Everything. Okay, AWS is managing everything. It will run the task on the cluster, on the agent. It will do auto scaling, task increase, auto scaling increase. Everything is managed by AWS. Now, this is very important. IAM role of task. Let's say you have a EC2. You have a EC2. You have installed EC2. So there is something called as profile. There is something called as profile, which is nothing but key value pair for that EC2. Okay. Then with that EC2, maybe you are a worker, and that's why you have an agent, and that agent have a task. So that agent can call with the help of profile, with the help of EC2 profile. Okay, it can call, agent can call ECS server, ECR, CloudWatch, and the SSM parameter store. What is this and why it call it? Why ECS is called? Let's say to restore EC2. Why ECR? To pull Docker image. Why CloudWatch? Maybe to send log. Why S4? To read write sensitive data. And this SSM parameter actually give role to task. Let's say role 0 to task 1, role 1 to task 2, role 2 to task 3. So actually it give role to task. This SSM parameter store. It return the task role. And why these rules are important? Because this task have some role, let's say R1. So based on that R1 only he can call service. Based on the R1 only he can call some service. Okay, to call any service, this task require a role. And from where this role is obtained, SSM parameter store. Okay, this is the only entity which can give the role. This was the important concept of ECS. Now, application load balancer, network load balancer, and classic load balancer. So this happens, user hit this ALB and there are some target groups, and under that target groups actually you will find EC2 instances running and those get called. This is our normal ALB scenario. Here also same scenario you will see, but instead of EC2 there are tasks T1, T2, T3, and where these tasks are inside the container. Okay, and that container are inside the agent, and agents are inside the EC2. So EC2 have a Docker, that's why you have a Docker content agent. That agent have a, that agent have a container, and container have a task, and that task is actually referred by the ALB. Similarly for this is A1, this is A2 of EC2, this is T3 in container of E3 which is in EC2. So ALB is integrated with the tasks. Let's say this task is running at 8080, 8082, 8084. Okay, so in this way we can expose tasks on ALB, and ALB is exposed on internet. Okay, so you can expose, okay, your Docker tasks or Docker container task or simply task, okay, with ALB. And this is also possible that one EC2 instance have multiple agents and multiple tasks running. Okay, multiple tasks. This is about ALB. Similarly, there is a NLB. If you want better throughput performance, then use NLB, otherwise don't use it. Classic not recommended because it is not compatible with various technologies. Okay, recent, don't have advanced features, so it is not recommended. Okay, about the data volume. Now this is task inside container which is run by agent which is inside the EC2. Okay, and which is inside AZ1. There is one more task T2 which is inside container, which is inside agent, which is inside EC2, which is inside AZ2. I want one file system like EFS so that both tasks can share it. So what is EFS? It's also serverless. It's a network file system. Two tasks can communicate with EFS, and it is actually a shared file system. Okay, so across the different AZ, you want a shared storage, so EFS can be used. Okay, again, container contain tasks. Container is inside agent is inside EC2 is inside AZ, and similarly here, and we have EFS, and with that EFS I can actually connect our tasks and they can share the data. But this is EFS. Okay, this is EFS, and this is a serverless. There is a FSX also. It is also serverless. They can make a combo. And they can both be used by your tasks T1 and T2, again, which is inside container, which are inside the agent, which are inside the EC2. Okay, so ECS can make use of both of them. This is for EC2. not for Windows, not for Lustre, only for EC2. You cannot imagine like S3 as FS. Okay, this facility is still not there. You cannot use S3 bucket as FS. This is just the FY. That's it for now. In next topic we will cover lambda functions and some other recent topics like DynamoDB, API gateway and AWS Cognito.